Alright, so we've been able to successfully define fundamental terms, physics, space and time. And we know that space and time form the stage, the bedrock for events, which are what everything that happens is made up of. So we need to understand very perfectly exactly what these terms mean. So we start with space and we're trying to understand now dimensions of space. The first question we'll ask ourselves is what is a dimension? And simply put, a dimension is a measure of degree of freedom. So it's a measure of degree of freedom. The term sounds a bit complex, but it's actually pretty intuitive. Dimensions are expressed in numbers, so you have 1D space, 2D, 3D, and so on and so forth. So on and so forth. And what these numbers mean is the number of axes, whatever you're describing, is permitted to move in. So we'll start with 1D space. A very good example of one-dimensional space is the number line. So we should be used to drawing this perhaps even from primary school. So let's say we have a line extending forward and backwards, and we have to place our origin. Space is not properly defined without an origin, because the origin forms your reference. Are you going above or below, up or down, with respect to your origin? So we'll number 1, 2, 3, -1, -3, -3. 1, 2, 3. So let's place someone. Let's call him H over here as negative over here, standing at this point. And how we say is that we say if we are asked where's the position of H, where is this person called H? You say okay, H is at -2. He or she is 2 units below the origin, to the negative part of the origin. So that's this -2. So this is what one dimensional. This is the essence of 1D space. H is at -2, and the origin of 1D space is a single zero. Origin 0. So as you can see, since we're dealing with one dimension, we need only one point to be able to describe. We need only one number to describe any points in 1D space. So as you move on and you get more complex, you enter 2-dimensional space, which a great example would be the graphs and graph sheets we use when plotting points in two axes. You have y-axis up here and x-axis this way, and as usual you'll have your points coming up from the origin, both in the positive and negative direction. Positive y goes up on y, and negative y comes down from y. And the origin this time is not going to be a single zero as it was with 1D space. This time it's going to be 0, 0, because you're going to have to describe that my origin is neutral at the x-axis, that's 0 here, and neutral at the y-axis, meaning it goes nowhere up, that's 0. So that's why you need 2 numbers to describe your motion. -1, -2, -3. So if I place a point here, and we're asked to find, okay, where is this point? Let's call it J. Where is point J? We won't use a single number this time because we're dealing with 2-dimensional space. So how it works is that you first of all call the x-axis. So you count from origin. That's 1, 2, 3, 3, and then the 2 dimensions are separated by a comma. So you have 3, 1. So point J is at 3, 1, and the origin for 2-dimensional space is 0, 0. And lastly, we'll deal with 3D space, which, as we've done before, 1-dimensional space had one degree of freedom, 2D had 2 degrees of freedom, and in 3D space we would also have 3 degrees of freedom. And the letters usually continue this way: X, Y, and Z. So by convention, usually we'll have Y going upwards, X going this way, and the Z-axis coming out of the page. As you can tell, the origin this time will also need 3 numbers. because the origin will be neutral on both x, y, and the z-axis, and you will still cut off your points as normal. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So given a point, let's call this somewhere here. Given a point here, to find this, you would have to find out where on each of these axes does this point lie. So this point here, let's call it K, is at, let me write it somewhere else. So K is at, remember you start with your x, then y, then z. So x, we have 1, 2, 3, and 4. So K is 4 units on the x-axis. One unit up on y, because that's 1, 2, 3, 4, and 1, 2, 3, also 4 units on the z-axis. So 1D, 2D, 3D, and you can go on and on, but then it becomes much harder to plot the points. But this is the basic concept with dimensions. A dimension is a measure of degree of freedom, and as you go on, you have increasingly more axes. Your origins will get more numbers, and to describe points in these axes, you will also need more coordinates. All right.